2011 projectiles, question 3a. A particle is projected from a point P on horizontal ground. The speed of projection is 35 meters per second at an angle inverse tan 2 to the horizontal, which will enable me to get my cos and sine. The particle strikes a target whose position vector relative to P is xi plus 50j. Find the value of x and then find the second angle of projection so the particle strikes the target. Okay, let's have a look at this question. We are firing a projectile from horizontal ground where the tan of the angle, we'll call the angle alpha for now, and it strikes a target, let's say it's here, and that is 50 in the j direction. Okay, well let's look at our angle first of all. We have alpha, tan is 2 opposite over adjacent, which gives root 5 for the hypotenuse. So cos alpha is 1 over root 5, and sine alpha is 2 over root 5. So my initial vector position is the cos. 35 is the speed, just 35 cos alpha, 35 by 1 over root 5, plus 35 sine alpha, 35 by 2 over root 5, and that's my I and my j. So I've got 35 over root 5 I plus 70 over root 5 j. So the distance in the I direction, or the x, is ut, because we have no acceleration. So I've 35 root 5 times t. That's equal to the x distance, or the I distance. So we're going to have time is equal to, it's going to be root 5 times I, root 5 times I divided by 35. So we can fill this into, we know if that's the time it takes to strike this target, we have the distance in the j direction. So the distance in the j direction, ut plus a half at squared, we can fill this information in now. We have 70 over root 5, 70 over root 5 times the time, which is root 5 over 35, minus 4.9, we just have our gravity in this case, times t squared, which is going to be 5 over 35 squared. Well, I'll just put it in root 5 over 35 to be squared. Get your I. So what does this simplify down to be? This we know is equal to 50. That's there here too. So it's going to give me, it cancels, so we're left with 2i minus, so we type this into our calculator, 4.9 by root 5 over 35 squared, we're going to get 1 over 50. So that's just going to be I squared over 50, square the I. And then if I bring the 50, well, I leave the 50 there because I'm going to bring the I squared across. So we're going to get multiplied by 50, we're going to get 100i minus I squared is equal to 2500. So okay, squared I squared minus 100i plus 2500 equals naught, and this is a perfect square. That's going to be I minus 50 by I minus 50. So then the I direction is also 50, it's the same as the x. So x is equal to 50, or I is equal to 50. Part 2, find the second angle. Okay, we need to use second angle, so the alphas will be different. So let's have a look at the time taken to get there. So ut is going to be equal to 50 in the x direction. So in the x we had 35, you see up here we had 35 cos alpha. So 35 cos alpha times t is equal to 50 in the I. So we can say that time is equal to 50 over 35 cos alpha. That simplifies 5 into both. It's going to give me 10 over 7 cos alpha. And if we fill that into our distance formula, we'll be able to get, when we think about a second angle, we're going to need to have some sort of quadratic to get a second value. So that's your ut is equal to plus a half at squared. So the distance in the I direction. So the distance in the I direction and j direction are both 50. But if we use the j direction and we put time in, we'll have sine over cos. So it's probably an easier way to do this question. So in the j direction, we had 35 sine alpha as the u. So my ut plus a half at squared. So 35 sine alpha by 10 over 7 cos alpha, you can see is going to give me a tan alpha minus 4.9 by t squared, which is going to give me 100 over 49 cos squared alpha. And that's going to be equal to 50. So what's this going to give me? 7 into 35 is 5, so that's going to be 5 tens, and sine over cos is tan, so we're going to get 50 tan alpha. You can see here the 49 and the 4.9 is going to give me a 10 on the bottom, so 100 over 10 is 10 minus 10 over cos squared alpha, which will change into 1 plus tan squared now in a minute. And then we know it's going to be a quadratic, so minus 50 equals naught. You've practiced this before. Cos squared alpha plus sine squared alpha is equal to 1. So we want to say this 10 by 1 over cos squared alpha. So if I put cos squared alpha there, cos squared alpha there, and cos squared alpha there, I'm going to get 1 plus tan squared alpha is equal to 1 over cos squared alpha. So I'm going to get 50 tan alpha minus 10 times 1 plus tan squared alpha minus 50 equals 0. So just multiply this out without rushing it. 50 tan alpha minus 10 minus 10 tan squared alpha minus 50 equals 0. So we want to make this positive, so we're going to have 10 tan squared alpha. We're going to have a minus 60, so we've changed the sign, so that's going to give me a plus 60, and we have a plus 50 tan alpha, so we're going to have minus 50 tan alpha, and these all divide by 10. So we're going to have tan squared alpha minus 5 tan alpha plus 6 is equal to naught, so I should factorize. Tan alpha by tan alpha gives me my tan squared alpha. 3 by 2 looks like the right minus in the middle, plus at the answer, they're both minuses, so minus 2 minus 3 is going to give me plus 6 when we multiply. So tan alpha is equal to 2. Now that was the original one they gave us, and tan alpha is equal to 3. So in this case, alpha will be equal to 71.6 degrees. And the original angle would have been 63.43 degrees. I don't think we were asked for that, but they're the two angles of projection that would enable this projectile to hit the target.